Above us, high in the heavens, there exists a marvel, one that floats silently in the blackness of space. The International Space Station, or ISS, is a shining beacon of human creativity and resolve. Suspended in orbit, it drifts alongside our planet, its intricate array of solar panels and scientific labs visible to the human eye. But beyond its appearance, the ISS is something much deeper. It is not just a structure. It's a testament to what humanity can accomplish when we work together against the odds to push beyond the boundaries of the familiar. A living, breathing symbol of our ever-expanding knowledge and ambition. And perhaps most remarkably, the ISS is a time capsule, capturing decades of human innovation and progress. Since its inception, this floating laboratory has become more than just a place for astronauts to live and work. It has been a dynamic platform for discovery, a testing ground for technology, and a laboratory where we can see the future of human exploration unfold before our eyes. And as it orbits the Earth, its story continues to evolve, offering insights that stretch far beyond the realm of space. The journey toward the ISS was a long one, stretching back to the early days of the space age. From the launch of Sputnik in 1957, which ignited the space race, to the first human landing on the moon in 1969, humanity has constantly strived to reach further into the cosmos. With each success, we learn more about how to live and work in space, and what we needed to sustain a human presence beyond Earth. In the years following the Apollo missions, space stations began to take shape. The Soviet Union's Salyut program and NASA's Skylab marked the first attempts at long-duration space habitation. But these early endeavors were small, temporary, and isolated, an experimentation in the unknown. The ISS, however, would be something different. It was to be the largest and most complex space station ever built, a platform that would unite the expertise of many nations and represent the cutting edge of space technology. Launched in pieces, with the first module sent into space in 1998, the ISS was not built overnight. Each component was carefully designed, tested, and placed into orbit, each contributing to a bigger and more sophisticated whole. Building a space station in the harsh environment of orbit is no simple task. Unlike the construction of a building on Earth, where gravity provides a reliable foundation, building in space requires a completely different set of rules. The ISS was assembled in orbit over the course of several years, with pieces arriving from different parts of the world, each launch a monumental effort in its own right. Astronauts, working in the weightlessness of space, would piece together modules from different countries, using specialized tools and techniques. Imagine trying to assemble a puzzle with floating pieces in zero gravity, with only a few minutes at a time to make adjustments and solve problems. Yet this is exactly what astronauts have done, creating a vibrant and functional station in the vastness of space. The result is nothing short of miraculous. The ISS is an architectural and engineering masterpiece, a sprawling network of laboratories, living spaces, and solar arrays, all working in harmony for 100 kilometers above the Earth. It's a product of global teamwork, where the collective knowledge and resources of many nations have been combined to push the boundaries of what's possible. What truly sets the ISS apart, however, is not just its engineering or scientific accomplishments. It's the unparalleled level of international cooperation that has gone into its creation and maintenance. The ISS is, perhaps, the most significant example of nations putting aside differences to work together for a common goal. The space station is the product of a coalition of 15 nations, including the United States, Russia, Japan, Canada, and nations in Europe. It's a place where astronauts from these countries live and work side by side. They share meals, solve problems together, and work on experiments that have the potential to benefit all of humanity. In an era of geopolitical divisions and conflict, the ISS has remained a symbol of global unity. It serves as a reminder that, for all our differences, we share one planet, one humanity, and one future in space. Every time astronauts float through the hatches and corridors of the ISS, they do so as ambassadors not only for their countries, but for all of humanity. This cooperation is not just a technical achievement. It's a profound statement about what can be accomplished when the world unites for the greater good. Life aboard the ISS is a constant reminder of the resilience of the human spirit. The station, though a marvel of technology, is also a test of endurance. There is no atmosphere, no gravity, no sense of day and night to anchor the crew to the rhythm of Earth. And yet, astronauts adapt. The lack of gravity presents numerous challenges. Simple tasks on Earth, like brushing teeth or eating a meal, become far more complicated in microgravity. Liquids float freely, requiring special containers. Food must be rehydrated, and astronauts must work carefully to prevent crumbs from floating away and causing damage to equipment. But perhaps the greatest challenge is the toll weightlessness takes on the human body. Muscles and bones weaken without the constant pull of gravity, so astronauts must exercise for hours each day to maintain their strength. The human body's response to space is not fully understood, and each mission provides new insights into how we might one day sustain ourselves on long journeys to the Moon, Mars, and beyond. Living in space is not just about surviving, it's about thriving. It's about pushing the limits of what we can endure and what we can achieve in the most extreme environments. And each astronaut's time on the ISS contributes to that ongoing journey of discovery. The ISS is more than a home for astronauts. It's a laboratory, a place where some of the most groundbreaking science of our time is conducted. Here, scientists study phenomena that can only be observed in the unique conditions of space, where the absence of gravity reveals the fundamental principles of physics, biology, and chemistry in new and unexpected ways. Astronauts aboard the ISS have pioneered experiments in everything from materials science to medicine, learning how human bones and muscles respond to long-term space travel, and discovering how fluids behave in zero gravity. They've tested the effects of radiation on human cells, researched the growth of plants in space, and observed how combustion behaves in an environment without gravity's pull. Each experiment conducted on the ISS has far-reaching implications for life on Earth. From creating stronger materials to understanding how diseases might be treated in space, the ISS is not just a stepping stone for future exploration. It's a powerful catalyst for scientific breakthroughs that could change life as we know it. The ISS is also a time capsule, preserving the best of human technology and innovation. From the life support systems that allow astronauts to breathe and drink safely to the sophisticated computers that manage the space station's functions, every aspect of the ISS is a testament to the advancements we've made over the decades. Many of the systems aboard the ISS were designed in the late 20th century, yet they remain the gold standard for space missions today. The space station's resilience speaks to the durability of human ingenuity. How, even with technology from the past, we've been able to continuously adapt and upgrade to meet the demands of life in space. As we look forward, The ISS will continue to evolve, its systems advancing alongside the ever-growing field of space technology. But one thing is certain: the ISS will remain a cornerstone of space exploration, encapsulating the pinnacle of human achievement in space. The ISS has laid the groundwork for the next chapters of human exploration. As we look beyond Earth's orbit to the Moon, Mars, and even farther, the lessons learned on the ISS will guide the next generation of explorers. It has given us a unique understanding of how to live and work in space for extended periods, how to maintain human health, and how to build the infrastructure necessary for future missions.